With the peak summer travel months just getting underway, Yosemite National Park will be a top destination. More than 4 million people visit that park each year.
A jagged tear in the earth has recently captured the attention of geologists and park authorities alike as a fresh rift has opened beneath the terrain of Yosemite National Park. The suddenness of its appearance and the unsettling speed of its widening have led experts to sound a rare red alert, a classification reserved only for the most severe geological events with the potential for widespread impact. This alert underscores the seriousness of the situation, as Yosemite, long celebrated for its granite cliffs, towering sequoias, and glacial valleys, now harbors a deep and ominous reminder of the volatile forces simmering beneath its serene landscapes. Before we start, smash the like and subscribe buttons for more updates. The rift itself emerged with little warning, initially noticed as a narrow crack threading through part of the park's wilderness. Within hours, the fissure expanded both in length and width, forcing immediate closures in the vicinity and drawing rapid attention from field scientists. Early surface measurements revealed that the crack was not superficial. Instead, it extended deeply into the crust, suggesting underlying tectonic stress or volcanic movement that could indicate a significant reawakening of forces long thought dormant. The red alert was issued not just for the dramatic visual impact of the rift, but for what it might portend, a shift in the geological equilibrium of one of America's most iconic natural reserves. What makes this event so alarming is the geological character of Yosemite itself. Unlike many other regions where surface cracks can sometimes be attributed to soil erosion or seasonal ground movement, Yosemite sits upon a vast foundation of granitic rock sculpted by ancient volcanic and tectonic processes. Any disruption here suggests pressures at great depth, where molten material, fault networks, and subterranean forces interact in unpredictable ways. The park lies within the broader context of the Sierra Nevada range, a landscape shaped by both uplift and glaciation, and beneath its beauty rests a record of seismic turbulence. The suddenness of this new rift evokes questions of whether a deeper volcanic or tectonic process is stirring once again. Geologists studying the fissure have identified faint tremors in the area, subtle seismic whispers that hint at underground activity. Instruments placed near the site have recorded vibrations not previously documented in the park at this intensity, adding urgency to their analysis. These tremors do not yet point to a singular outcome, but their presence raises the possibility of magma movement or tectonic shifting. Either scenario carries profound implications. Magma migration would suggest volcanic potential beneath Yosemite, a reality that could alter both the landscape and the safety parameters for millions of visitors. On the other hand, tectonic slippage in the region could herald earthquakes of magnitudes capable of reshaping valleys, damaging infrastructure, and setting off landslides across the granite walls. The red alert status has also been informed by the sheer unpredictability of how such a rift might evolve. Historical records show that fissures of this kind can sometimes stabilize, serving as pressure relief points with minimal long-term consequence. But in other cases, they have been the harbingers of much larger ruptures, precursors to seismic events of devastating scale. The uncertainty of which path this new rift will take has left officials little choice but to prepare for the worst, while urging caution and restricting access to the areas most likely to be affected. The decision to declare a red alert is not taken lightly, as it instantly escalates preparedness measures and draws national attention to the potential hazard. Beyond the immediate geological concerns, the implications for Yosemite's ecosystem are staggering. The park's ecosystems are finely tuned to specific elevations, soil compositions, and seasonal cycles. A rift that alters groundwater flow or destabilizes cliff formations could have cascading effects on wildlife corridors, plant growth, and river systems. If underground magma is involved, thermal changes could introduce hot springs or even fumaroles, altering habitat conditions for countless species. For a landscape that has endured for millennia, even a relatively small geological upheaval could rewrite the ecological map in ways scientists are only beginning to speculate. The human element cannot be overlooked either. Yosemite is not only a national treasure, but also a hub of tourism, research, and cultural significance. Millions of visitors walk its trails each year, stand in awe of El Capitan's granite face, and marvel at the flow of Yosemite Falls. The sudden appearance of a yawning rift beneath this sanctuary introduces an undercurrent of danger that could alter how people experience the park. Roads, lodges, and visitor centers all rest upon terrain that is now under question, and the possibility of further cracking or shaking raises concerns about the safety of both tourists and the staff who call the park their workplace. For the scientific community, the rift represents a rare chance to observe geological forces in real time within a landscape as iconic as Yosemite. Specialists have already descended upon the area, setting up monitoring stations, drilling small core samples near the fissure, and employing aerial surveys to map the changes with precision. Data from satellites are being cross-referenced with ground-based sensors to track micro-movements by the hour. This intensive observation campaign is aimed at deciphering whether the rift is a singular anomaly or the first chapter in a larger geological event. Each finding brings a mixture of clarity and new questions, further amplifying the sense of urgency attached to the red alert. At the heart of the concern is the possibility that this fissure could be tied to deeper magmatic systems beneath the Sierra Nevada. Though Yosemite is not commonly thought of as a volcanic region in the way Yellowstone or Hawaii are, it was born from volcanic and magmatic roots. The granitic walls and domes that define the park are the cooled remains of immense magma bodies that solidified underground millions of years ago. Some geologists argue that dormant magmatic chambers could still exist at depth, and a fissure of this nature might signify pathways opening for new material to rise. If true, this would mean Yosemite is not as geologically quiet as once assumed. Another dimension of the crisis involves the potential for landslides. The towering cliffs of Yosemite, while breathtaking, are also prone to rockfalls even under normal conditions. A shift in tectonic stress or a widening crack beneath the park could destabilize massive sections of granite, unleashing catastrophic slides into valleys below. The rift's location is being closely studied in relation to known fault lines and cliff faces, as even a moderate adjustment in underground pressure could trigger chain reactions along weakened zones. The memory of past rockfalls, some of which have altered trails and caused fatalities, heightens awareness of how quickly conditions can shift in this rugged environment. Hydrology is another pressing concern. Yosemite's rivers and lakes are fed by snowmelt and underground water systems that weave through cracks in the granite. A new rift of this scale has the potential to redirect water flow, draining meadows, creating sinkholes, or even producing new springs. The delicate balance of water supply in the park, vital not only for wildlife but for downstream communities, could be disrupted if subterranean channels are altered. Geologists and hydrologists are therefore collaborating closely to model how the fissure might influence groundwater systems and surface water patterns in the near future. The psychological impact of the red alert cannot be ignored either. Yosemite has long been a place of stability in the American imagination, a cathedral of nature where timeless granite and ancient trees provide a sense of permanence. The sudden reminder that the earth beneath it is still capable of dramatic change unsettles that image. For many, the idea of a rift opening beneath such a sacred landscape is a stark confrontation with nature's unpredictability. It serves as a reminder that no matter how carefully humanity manages parks and preserves, the forces of geology remain beyond control or containment. One striking aspect of the situation is the role technology now plays in tracking such phenomena. In decades past, a fissure might have gone unnoticed until it caused visible destruction. Today, with satellites orbiting overhead and seismic sensors embedded throughout the region, the rift's growth is tracked in minute detail. These tools allow for unprecedented insight, but also expose just how fragile the balance beneath Yosemite truly is. With every centimeter of expansion recorded, the reality of the crisis becomes more tangible and more pressing, magnifying both scientific curiosity and public concern. As scientists study the rift, debates are emerging within the geological community about what mechanisms might be at play. Some argue for tectonic extension, suggesting that the Sierra Nevada is slowly being pulled apart along hidden faults. Others propose magmatic intrusion, pointing to the tremors as possible evidence of molten rock forcing its way upward. Both explanations carry weight, and both highlight the reality that Yosemite's deep geology remains incompletely understood. This lack of consensus only adds to the urgency of maintaining the red alert as predictions about the fissure's future are still clouded with uncertainty. The scale of monitoring and preparation has expanded far beyond the boundaries of the park. Neighboring communities are being briefed on the situation, as seismic or volcanic activity in Yosemite could ripple outward, affecting regions well beyond its granite walls. Infrastructure such as highways, power lines, and reservoirs in the Sierra Nevada all depend on geological stability. A rift beneath Yosemite might therefore represent not just a local hazard, but a regional one, with implications for California as a whole. The state, already attuned to the risks of earthquakes, must now consider whether a new center of geological activity is emerging in its mountainous heart. For visitors, the rift introduces a paradoxical allure. On one hand, it poses undeniable danger and has led to the closure of trails and sections of the park. On the other, it draws fascination as a living display of the Earth's power. There is a magnetic quality to watching landscapes change in real time. And despite restrictions, some people feel compelled to glimpse the rift for themselves. Park authorities are working to balance public curiosity with safety, recognizing that the spectacle of nature's unrest can be as compelling as its beauty. What unfolds next remains uncertain. The red alert stands as a testament to both caution and respect for geological processes beyond human command. The rift beneath Yosemite is more than a crack in the ground. It is a reminder of the restless energy that shaped the continent, the forces that built mountains and carved valleys. Whether it closes quietly or expands into something far more consequential, it has already altered the way people view Yosemite. The park, once considered a bastion of stability, now sits at the center of an unfolding drama where stone itself seems alive, shifting and splitting under invisible pressures. The very fact that this event is occurring in a place so deeply woven into the cultural and environmental identity of the United States magnifies its impact. Yosemite is not just a park. It is a symbol of natural grandeur, of the conservation movement, of landscapes preserved for future generations. The sudden emergence of a rift threatens not only the physical stability of the land, but also the symbolic stability it represents. It forces a reevaluation of what permanence means in the face of Earth's continual transformation. Even as teams continue their round-the-clock surveillance of the fissure, the unpredictability of geological forces looms large. The issuance of a red alert has made it clear that this is not a trivial anomaly, but a profound signal of subterranean unrest. As monitoring continues, scientists remain on edge, aware that each day could bring new developments, more tremors, a widening of the crack, or signals of deeper volcanic processes stirring. The watch over Yosemite has become not just scientific duty, but a collective vigil over one of the planet's most cherished landscapes. The rift beneath Yosemite has already commanded a level of attention unlike anything the park has faced in decades. Yet there are still countless dimensions to this event that stretch far beyond the immediate geological and ecological concerns. While the red alert is an urgent signal for caution, it also acts as a spark for broader reflections on science, on society, and on the ways in which humanity attempts to coexist with forces far older and more powerful than itself. This rift is more than a crack in the earth. It is a reminder of how fragile the balance between people and the planet truly is. One of the most striking aspects of the unfolding situation is the way it challenges existing frameworks of hazard management. Yosemite has long been equipped to deal with dangers like wildfires, rockfalls, flash floods, and snowstorms. These are predictable seasonal or environmental hazards, well documented and often mitigated through established emergency protocols. But a deep geological rift, paired with tremors and potential magmatic signals, is far outside the normal scope of preparation. The red alert underscores how certain natural events defy categorization. Park management now finds itself navigating uncharted territory, drafting contingency plans that range from mass evacuation procedures to rerouting water supplies, all while under the scrutiny of a global audience following each development with rapt attention. This crisis also forces a deeper examination of the history beneath Yosemite's granite facade. The park is known for its glacially carved valleys and soaring cliffs, but beneath that iconic scenery lies an ancient record of fire, uplift, and transformation. The Sierra Nevada batholith, which underpins Yosemite, is itself the hardened remnant of massive magma chambers from a time when volcanic arcs dominated the region. While those chambers solidified millions of years ago, their legacy still resonates in the rocks. The sudden opening of a fissure here reminds geologists that these ancient forces are not relics. They are part of a continuous cycle of planetary change. It is possible that the rift is not an isolated event, but rather a signal that Yosemite's deep geological story is still unfolding, far from finished. Cultural dimensions also play a vital role in understanding the magnitude of the alert. Yosemite is not just a landscape of cliffs and waterfalls, it is a place deeply rooted in indigenous history. For the Awanichi people and other native groups connected to the valley, the land has long been imbued with sacred meaning, each formation carrying stories passed through generations. A sudden geological rupture here reverberates beyond scientific concern, touching on spiritual and cultural interpretations of what it means for the Earth to shift so dramatically in a place of such profound significance. Some indigenous voices may view the rift not as a mere hazard but as a powerful message from the land itself, a reminder of the cycles of renewal, destruction, and transformation that govern existence. The tourism industry surrounding Yosemite finds itself in an uneasy position as well. The park attracts millions of visitors annually, contributing billions of dollars to local economies and sustaining countless businesses. Hotels, restaurants, tour companies, and outdoor gear suppliers all rely on the steady flow of travelers eager to experience Yosemite's wonders. The sudden declaration of a red alert disrupts this economic rhythm, casting uncertainty over an industry that depends heavily on the image of Yosemite as a safe and eternal sanctuary. The presence of a fissure and the potential for seismic activity introduce an unpredictability that may linger for years, reshaping how tourism markets the park and how visitors plan their journeys. The educational value of the event, however, cannot be overstated. Already schools, universities, and research institutes are using the situation to spark discussion about earth sciences, geology, and the nature of natural hazards. Students who might otherwise learn about tectonics and volcanism in the abstract now have a living case study unfolding in real time within a globally recognized park. The imagery of a fissure cutting into Yosemite's granite, paired with the gravity of a red alert, provides a visceral entry point into scientific inquiry. For many, this moment may inspire new generations of geologists, seismologists, and environmental scientists eager to unravel the mysteries beneath the surface. Global scientific collaboration has been invigorated by the appearance of the rift. Researchers from around the world, representing institutions that study earthquakes, volcanoes, and tectonics, have begun sharing data and interpretations across networks. Satellite imagery from international space agencies is being analyzed in conjunction with ground-based seismic arrays. Experts from volcanic regions in Iceland, Japan, and Italy have been consulted to compare Yosemite's fissure with similar phenomena elsewhere. This exchange of knowledge highlights the interconnected nature of Earth sciences. What occurs in California may illuminate processes occurring under faraway mountains or rift valleys. Yosemite has become, in effect, a global laboratory. One of the most compelling scientific avenues emerging from the rift involves the study of stress distribution in the Earth's crust. Geologists theorize that even seemingly stable mountain ranges like the Sierra Nevada can harbor complex networks of fractures and weak zones, invisible until activated by shifting pressures. The Yosemite fissure may provide rare direct evidence of these stress patterns at work. By monitoring its expansion, researchers can learn more about how stress accumulates, how it is released, and how cracks propagate through solid rock. Such insights could transform how scientists assess seismic risk, not only in Yosemite, but in mountain ranges and tectonic regions around the globe. Beyond geology, the red alert has profound environmental implications that stretch into climate science. Yosemite's ecosystems, already under stress from rising temperatures, shrinking snowpacks, and increased wildfire frequency, now face an additional layer of uncertainty. If the rift alters water flow or reshapes valleys, it could accelerate ecological changes already in motion. Meadows that serve as critical habitat for birds and amphibians might dry or flood unexpectedly. Alpine lakes could drain into subterranean channels, disrupting aquatic life and affecting downstream water supplies. By introducing new variables into an already stressed environment, The fissure amplifies the urgency of understanding how Earth systems interact under the combined weight of climate change and geological upheaval. The symbolic power of the rift extends even further. Yosemite has long been held up as a testament to conservation, a place where humanity's better instincts to protect and preserve were first put into practice. It is often cited as a birthplace of the modern environmental movement. The sudden rupture of its land challenges that narrative, demonstrating that no matter how carefully people protect a landscape from logging, mining, or development, the Earth itself retains agency over its form and future. This event forces a sobering acknowledgement. Preservation cannot halt tectonics. It underscores the humility required when discussing human efforts to safeguard nature. The rift also has geopolitical echoes.